Hello, my name is Stuart Roberts. I'm one of the co-founders of Pitt Street Research. And joining me today from Sydney on Monday, the 6th of May 2024, is Dr. Paul Dalgleish. He's the Managing Director of GreenHy2, HYG. Paul, good afternoon.
H2G.
H2G, I should say. Let's say that over again so the punters know what a great company this is. GreenHy2, ASX H2G. I've got it right.
Yeah.
Okay, remember those three words, folks. You're Dr. Paul Dalgleish, Paul, and the reason is you're an engineer by training, and you've got an honours degree in that discipline, and you've got a PhD in business. So it's fair to say you've got a pretty sharp business head on your shoulders. Would you agree?
I hope so. That's what my shareholders hope too. So yeah.
Right. Prior to GreenHy2, you built up UGL from just about nothing. Started with Kilpatrick Green. And I think 30 million in revenue. And before you were done, it was a 1.2 billion a year revenue company.
Yeah, it was. You got a good memory.
Right. And then after that came RCR Tomlinson as well. So you've run some pretty big companies. You know a thing or two about bidding on contracts profitably. You've now stepped down to run a company that I need a magnifying glass to see the market cap at the moment. Although I'm expecting that will change. Tell us what prompted you to invest in GreenHy2.
The technology, really. I could see that that we needed a storage system for renewable energy. I mean, we all know the wind doesn't always blow and the sun doesn't always shine. And so we needed a storage system for energy. And then when you look at the opportunities there, you've got lithium batteries, which is not that renewable. And then you've got very little else except for solid state hydrogen storage in metal hydride. When you look at gaseous storage of hydrogen, you can see all the problems there because it is 700 bar. That's okay for the refining industry, but it's not okay for the average person or the average electrician, I might say, working in an essential energy for a utility. So when I realized that metal hydrides were a great dense form of storing energy and as a solid and very safe, and that it was really just a matter of understanding the technology and commercializing it, becoming commercialized, that it provided a lot better opportunity. A battery that's 100% recyclable, a battery that doesn't degrade over time, that gives you 100% of its capacity at all times. If it's full, it's full, and if it's you can use the entire 100% and then fill it back up again. You don't have depth of discharge and depth of charge issues. You don't have heat interference with it. These are installed in the Alps and in very, very hot environments. So it's more of a chemical process, and it's very safe. So I could see the technical advantages of it. So from my attraction was, wow, that's a really solid solution. It allows for diversification of the energy market. So for people who can't be connected to grid or people who are on diesel, they can generate their own power, and they're 100% renewable, and their OPEX is virtually zero once they've paid the CAPEX. So when you're looking ahead, you're not at the mercy of anyone raising your electricity prices, because all you've got is a little bit of maintenance on your electrolyzer. You change the potassium hydroxide once a year, and you test your hydrogen meter, and that's your OPEX. It's very lean. Solar panels, you wash them down, clean them, and that's about it. So I just love the technology. It just seems so sensible, and that was what attracted me to the business.
Right. Let's summarize the technology. Hydrogen at solid state is able to capture solar energy for then disbursement to the grid when you need it to. And you can build these systems with a fair degree of modularity, so they can go out to all sorts of remote sites, and they don't take up too much room to generate a fair bit of electricity. Do I have that down?
Yeah, so solar power, we go through an electrolyzer to produce the hydrogen gas. And so that's really just like a reverse battery. You put some power in and get the hydrogen out, and you make oxygen as well, actually. And then we store the hydrogen as a solid. It goes into a lattice, a metal lattice that's just we'll store it as a solid, so as a metal hydride. It's a ferrous titanium hydride, and it stays there forever if you leave it there. It only stores 40 bar maximum pressure. When we want to generate electricity, we open up the other side and we heat it a little bit and we put it through a fuel cell at low pressure again. And it's just, again, a fuel cell. It uses electricity. We add oxygen from the air to it and we produce pure water as the byproduct. And electricity, so we make electricity. And it's very, very dense because the density of the solid is, 15 times at the same pressure the density of hydrogen gas. And it's 10 times the density of lithium in power storage. Right. So yes, it's a solid medium. In a container, shipping container, we can store 8 megawatts of chemical power, so 4 megawatts of electrical power.
Right.
It's a lot of power in a small space, and you don't have the issue of fires and things that you do with lithium and heating up. So it's that's how it works, and it comes in shipping containers. We have small ones that are 0.5 megawatt hour of storage, which means run a house, the average house, for 20 days without any solar input. And then we have ones that are in a 20-foot container, and they go right up to 4 megawatt hours, and then we can put 4 of them together in a tower, what we call a tower, and they can have 16 megawatt hours of electricity. So you can store quite a fair bit of electricity as a solid hydrogen.
And you've tested this out. We had a test site up near Port Stephens, north of Sydney.
Yeah, that's correct.
It worked like a dream in terms of being able to supply energy to a little guest house in a national park. But now you've got some serious potential commercial collaborators, such as Telstra and Essential Energy. Talk to us about how that's evolved.
Well, so the trial at in Northern New South Wales was for Essential Energy, and again, it's in a national park. So one of the things about national parks is that transmission lines have a tendency to get hit by trees and cause bushfires. We want to get rid of them. They certainly don't want to put lithium in there that could just be another source of bushfire. We trialed just a small. It's a little solar installation plus the battery, 10-foot container, which is not very big, 3 meters by 3 meters by a couple meters high, and yes, it ran for a full year, no outages. So 100% of the power has come from the grid, come from the renewable energy, nothing from the grid, and operating costs is virtually zero. So right. For people like the national parks, it's ideal. Places where they haven't got power in, there's lots of campsites where people want to actually have a barbecue and they can't have an electric barbecue because there's no electricity. And they don't want gas fires there or gas barbecues. There's lots of places that have diesel installations. So a lot on 100% diesel. So you'll notice in the Northern Territory there'll be heaps and heaps of communities on 100% diesel. And for those poor communities, they get a flood or something, then they're delivering diesel by helicopter. Right? So the cost is astronomical, and they just need to get investment dollars to put in solar metal hydride advanced technology battery of ours, and they can be at zero operating cost, and they don't have the fear of ever running out of diesel either, or the cost of diesel.
Right, and you've done a lot of work on the economics of your solid state system, and it beats diesel every time.
Yes.
It beats lithium in terms of the expected replacement times. So you're getting in a pretty good competitive position there.
Yeah, on an MPV basis, we're well in front of 100% lithium compared to our 100% of our hydride basis. We're probably half the net present cost, and we also see that we get pretty short payback periods against 100% diesel. But again, it's only the people who are offsetting small capex against big opex. Whereas we've got more in the capex, and not a lot more in the capex, but more in the capex and virtually very little opex going forward. So you're slowly getting that message around to people. People who are looking at an NPV basis, we're coming in very competitive.
Right. Now, when people talk about the energy transition, inevitably the subject of battery storage comes out, which is where you are. And most people talk about vanadium redox flow batteries. Where do we sit compared to that particular paradigm?
Well, I think we're seeing that the Northern Territory were doing a trial on that, and I think from a cost point of view, it was still quite expensive from the flow redox battery point of view, and you got to wonder, we've got a commercial solution that's cheaper already. I think that given our performance recently, that we've got to be the choice, because we've got 100% recyclability, right? We don't use up any metals in the process. We put ferrous titanium in there, but it's recyclable.
Right.
So we're not using any metals or anything in the life of our system.
Compare that to lithium-ion batteries, where the big discussion there is how the heck do we make these things recyclable? And there are companies with solutions, but it'll take a while.
But that's a good business. I mean, black mass recycling will be a great business because there's going to be lots of lithium to recycle. Right. And yes, and it's hard and it's a bit tricky, and they haven't quite got there yet. But I think again, that's good, but still we don't want to mine lots and lots of more lithium, if that makes sense. We don't need to mine our raw material here. We've got hydrogen in the air. Right. It's from the water. We just get the water. It's got hydrogen. We've got plenty of water, and we recycle it, and it turns back into water. Right. So it's our raw material is quite. Well,
I take it back to that big proponent of hydrogen, Dr. Andrew Forrest. He's at pains to encourage people to realise the technologies here are real for hydrogen. Now, he's not an investor in your company yet, although I suspect he should be taking a look. What you've got over him is the ability to make these things smaller.
Yeah, so they're looking at the big end of town, and they've got reasons to do that because they want to make a urea plant or something like that. And we're looking more at the diversified smaller market. But that diversified smaller market, conservatively, if you look at all of the standalone power supplies, they call them SAPs, in the utilities, that means Essential, Ergon, Western Power, Horizon, Northern Territory Power and Water, South Australia Power. You'll see that it's a $140 billion market. So that's just taking out 1 to 5% of the current customers who are very, very expensive. So you'll see that the way that the utilities work on their systems, they say 1% of my customers cost X dollars. So in Essential, they say 1% of their customers cost 20% of their grid costs.
Right.
So those people are on long swirl lines, which come with all sorts of problems. They come with lots of maintenance, a high cost, and bushfire issues. Plus they fall down, burn down, get flooded down, get blown down, and then the user doesn't have his electricity anyway. And so when you look at those customers, they're better off on a local mini grid, right? Standalone power system, than they are connected to a grid that's miles away. And Australia's got a low population density and centralised power, so there will never be a national grid, and it'll never work that way. And so and the maintenance on those big long lines, and they're swirl lines, so they're single wire, so they're very high risk of bushfires, single wire earth return. And so we see that Western Power will quote that 1% of their customers cost 50% of their grid costs.
Right. And
so they've got to remove all these people. So if you think of 1% of Western Power's customers, that's 23,000 customers.
Right. So we've reached the stage that where a lot of people are going to be talking about your solution to solve a serious problem that all these utilities have. What's the next year or so hold for you in terms of what you're hoping to achieve between now and say Easter next year?
Well, we're hoping to achieve that there's a push to remove diesel as the solution for SAPs.
Right.
And once diesel is finally accepted as being greenwashing as a solution, then of course we'll be the most competitive solution. That opens up that $140 billion market to people who have got a solution like ours, and so far we don't really have a competitor in that space. And as they move away from lithium again because of the bushfire issues and all the other issues surrounding raw materials for lithium and the fact that it's not really green, and they start to enhance the fact that hydrogen is green and it comes from water and goes back to water, then we're hoping to achieve a lot of recognition around that, the market to wake up to that, or the industry to wake up to that and start to go, well, seriously, we can't be putting in diesel. You see Telstra doing it. Now they're aware of it. So other major companies and utilities will have to slowly come to that same awareness. And then so we're looking at hopefully selling lots of revenues in those spaces. We've got a lot of tenders in at the moment. We're hoping that to get some success, and we're also got that market where it's 100% diesel. Anyone who's got 100% diesel in can swap over to our technology with some solar and get a payback period in a reasonably short time. Admittedly, some of the mines are only 5 years, so they don't see it that way. But if you've got a 15-year life of a mine, then it's the calculation is quite simple and there's a big advantage.
I don't know a mining company that doesn't want to reduce their dependence on diesel for anything. So you're selling the right space there. The company is asset light. You don't actually make the systems. You outsource that to suppliers in Europe and elsewhere. Tell us about the supply chain if I become a customer.
So the supply chain, the technology for the metal hydride comes through a company called GKN. They're actually a London Stock Exchange listed company. They were under a company called Melrose on the London Stock Exchange. They've been spun off to a company called Dalgleish, and they're still on the London Stock Exchange. But they came from an old English company, GKN, but a lot of manufacturing is done in Germany and northern Italy. So their head office for manufacturing of the GKN technology, the metal hydride, is in Brücken, in Bruneck, I should say, in northern Italy. And then the electrolyzers and fuel cells, they're both European suppliers at the moment. So we use Enapta electrolyzers and fuel cells from a number of places, Proton and others, and Nedstack. They're Dutch. So we source those into the systems. But and then we add the IP around the solar and the design and the system additionally as well. So we'll GKN will help model it too. They'll model it for us as well. They have a pretty good digital platform on this system of theirs, so we can communicate to it no matter where it is. We can see it. We can maintain it remotely. We can look at all the data in it. We can see how much energy it's got in it, how much storage we have, how many days of storage we have, what the solar is doing. So we can see everything that's happening in the system, and we can also maintain it. It also has some AI in it, where it tunes itself against a virtual machine from the simulations, and we can actually run a virtual machine and the actual machine in parallel, and then we can use it as what we call a digital twin. We can see whether there's any maintenance issues in the system. So that's all the GKN technology, and then all the additional stuff that we add out here with the IP of the installations and getting all the solar and the right sizing and the mixture of load and operations we do locally. We may, if we get enough orders, we'll assemble here locally.
Right. So made in Europe, but with a lot of secret sauce coming from Australia.
Yeah. The IP about the units, for the metal hydride, are all GKN technology, and they're quite they're probably the most advanced of that in the world. And then we can put any sort of electrolyzer and fuel cell together, and the rest of the technology together how we'd want. but there is people that we've been working with for a while, and GCAN have been working with a while, like an Apta and MedStack and Proton, and those people who we can go to quite quickly because we've already integrated their systems. But in the bigger systems, we're a lot more open to different electrolyzer suppliers and fuel cell suppliers, because we can create some competitive tension because the units are bigger and they cost a lot more. So we can get a number of tenderers or bidders to come in and price them.
Well, Dr. Paul Dalgleish, thank you for sharing this with the story, which I don't think many investors are all that familiar with, given that you're a relatively new company on ASX. Good luck with what's coming next, and let's hope that some serious competitive tension comes into the market, where you're a winner against those losers called diesel and lithium.
Diesel equals bad. Yes.
Thank you for talking to Pitt Street Research.
Thanks.